Good morning, students. Today we are going to talk about bottom-up parsing. It is we are coming after a long time. You remember that we talked about top-down parsing in our last class, and that was called predictive parser or LL1 parser. Again, let me recall that a top-down parser tries to mimic the leftmost derivation of a sentence starting from the start symbol using the production rules. The LL is an abbreviation. The first L, leftmost L, stands for left to right, that is, we'll be scanning the text, the sentence left to right, which is normal. And the second L stands for leftmost derivation. It is mimicking leftmost derivation. It is called top-down parsing because it tries to create the parse tree from the top, from the root to the sentence to the leaves. Now, in bottom-up parsing, it is just the reverse. It is, there are many types of bottom-up parsers. One example could be operator precedence parsing, and we will not talk about that because it has limited use. We'll primarily talk about LR methods. Again, the first L stands for left to right scan of the sentence, maybe a program, and the second R means reverse of rightmost derivation. We'll elaborate on that, and in this particular kind of parsing technique, we'll talk about three parsers. One is LR0 or SLR, the second one is LR1 or canonical error, and the last one is LALR. But students, if you understand the LR01, then the second and the third parsers are actually very easy to understand. So let us look a little more deeply into what is meant by bottom-up parsing. See, I have a grammar, very simple grammar, frankly speaking, with four production rules. S produces small a, capital B, small e. A produces capital A, small b, small c, or small b, and capital B produces small d. You understand that the capital letter, italicized letters are basically the non-terminals or the variables, and the bold small letters are the terminals or the characters in the sigma or the alphabet set. Now let us look at this particular rightmost derivation of a particular string sentence A, B, B, C, D, E. Now you see that from S, using a rightmost derivation, I get small a, capital B, small e. Now what is the rightmost non-terminal here? Capital B. So I have to replace capital B using some rule. There is only one rule. So I replace capital B by D and I get the second sentential form small a, small d, small e. Now I see that my sentence is a little far. So I apply the recursive rule for capital A, which is replacing this capital A by capital A, B, C. So small a comes as it is, DE comes as it is. This capital A is replaced by capital A, small b, small c. Then I replace capital A by small b, and therefore it comes as A, B, B, C, D, E. If I want to do it the reverse way, then I start with this sentence as I have seen here. Now to get back by one step to the previous sentential form, I need to replace this B by A. Why? There is a rule like A produces B, and this B can be, so this B appears at the right hand side of some production rule, and then this B can be replaced by this capital A, and then I get the previous sentential form, and exactly that is what we are doing here. Now from the last but one sentential form, I see that, see here also I have this small b, and I can also say that this small b appears at the right hand side of this production rule, capital A produces small b. But this is not the one which we can replace. Why? Because if I replace that, then I do not get the previous sentential form that I would have if I did it in a rightmost manner. So what I have to do is I have to replace capital A, small b, small c, which is also appearing at the right hand side of a particular production rule, and I replace that by capital A. So now the sentential form becomes small a, capital A, small d, capital E. Now naturally, the question that is coming to your mind is, given a sentence or a sentential form, how do I find out this underlined substring? There may be many matches for the substrings which could appear in the right hand side of these production rules, but only one of them will be actually valid for valid to be replaced. So that is the trick that we will learn, that the bottom up parser uses, or the bottom up parsing algorithm uses. That is the trick. That is what we are going to learn. But to get the preliminaries, let us again look at how we are building the parse tree from bottom to top. See, this is the sentence that I have. The first replacement was this B is used as the right hand side, and this capital A was used as the left hand side, and I got this capital A as the parent of the child small b. Now what is the sentential form? I have to look at the top symbols, small a, capital A, small b, small c, small d, small e. Now once I am here, then what is the next thing that I am doing? I am replacing this capital A, capital B, capital C by a capital A. So exactly that's what I have done. I have created a parent which is capital A, the node capital A, and it has three children, capital A, capital B, capital C. Now what is my sentential form? This small a, this capital A, this small d, this small e. Always I have to take that the root of the subtrees that are already obtained. Now this is a singleton subtree, this is a singleton subtree, this is another singleton subtree. So what we can do is we collect the roots of the subtrees, small a, capital A, small d, small e, and that is my sentential form as of now. Now next what I do replacing this D by capital B, and that's what I depict in this particular diagram. And then I have capital A, capital B, and small e. And then I use this entire substring to be replaced by capital S, and I get my parse tree back. So you see that this is the way I can get the total parse tree from the bottom to the top, from the leaves to the root. So therefore this technique is called bottom up parsing technique. I hope that this part is understandable and you have understood it. Of course, if you have questions, you can ask me in the Google Classroom, and I will be obliged to answer all those queries. But please read these, listen to these lectures very minutely and very slowly. You can easily rewind, you can easily, if you know it, you can fast forward. If you do not understand it, you can come back to the slides and my explanations. And even after that, if you have questions, you can ask that question to me in my Google Classroom. So next slide, let me go. Next slide is a bit interesting, and this is the first kind of preliminaries which I need to work with when I go for bottom-up parsing. We will encounter a term called handle. Now you remember that from here to here, so this is the last step in my rightmost derivation. This was the second last step in my rightmost derivation. From here to here, how did I reach? By replacing this b by capital A. So what is the beauty of this b? This b is appearing at the right hand side of some rule, but maybe you can say this b also appears at the right hand side of some rule. So why this b and not this b? Again, the answer is simple, that if I replace this b, then this takes me to the second last step in the rightmost derivation from top to bottom, right? And I am doing a reverse of rightmost derivation. So it is very important to understand that every substring here that matches with some right hand side is not the one that I want to substitute. I want to substitute only that substring that has two properties. The first property is simple, that it has to appear in the right hand side of some production rule, but that is not sufficient, that is necessary. The other condition, which is sufficient condition, is that once I replace that right hand side substring by the corresponding left hand side, then whatever I get is the sentential form that was one step backward in the rightmost derivation of the same sentential form, right? So in the next step, you can see that this D also appears at the right hand side of some production rule, but I'm not using this D for replacing. I'm using capital A, small b, small c. Again, not because that appeared at the very first, but because only by replacing this, I go back to the previous sentential form, right? Uh, uh, so the idea of the handle is the substring in the, so you see, in first step you are given with this sentence, in the second step you are given with this sentential form, in the third step you are given with this sentential form, in the fourth step you are given with this sentential form, and then in the last step you have the start symbol. So in every step, you have to find out a substring that matches with some right hand side 1 and 2, that by replacing that right hand side with the corresponding left hand side, you can always go back to the previous sentential form, which you could have derived in a rightmost manner. So that is the definition of a handle. A handle is a substring of the sentential form at hand that matches a right hand side of a production, and by replacing that, you can go back to, you can actually go back to the previous sentential form. For example, if you look at it here, this B is also a substring that appears in the right hand side, and that is also the first one that you encounter from the left. But this is not a handle, because if I reduce it to capital A, then whatever I am getting is small a, capital A, E, and from there I cannot reach my desired start symbol, right? So finding out the handle is therefore the major task that our bottom-up parsing algorithms do. So what is the lesson from this slide? From this slide, I understand that we have given a formal name to the substring of any sentential form that I am trying to parse, so that if I replace that substring by a corresponding grammar rule, then I get back my previous sentential form that I could have achieved in a rightmost manner to arrive at the given sentential form. I think this should be very clear to you. Again, if not, come to me, come to the class, or even post questions in the Google Classroom. Now, next we go to the next slide. Now we'll be talking about prefix. First, what is a prefix? Then what is a viable prefix? And then what is the longest viable prefix? Very important terms and very simple terms. No rocket science, very common sense terms. First, a prefix. If I given a string, what is a prefix? From the left, I take any bunch of symbols, that's a prefix. Like, this is my string, forget about the underlining, that does not make any sense now. This string is like this, then this A is a prefix. This AB is also a prefix. Similarly, ABB, ABBC, ABBCD, ABBCDE, all are prefixes. Now you see the handle is, however, this one. I mean, the handle is separated from this text using angular brackets, just for your convenience. Now, any prefix that does not go beyond the right end of the handle is a viable prefix. So this is my handle, and therefore any prefix that goes beyond this B is not a viable prefix. What is a viable prefix? A is a viable prefix, AB is a viable prefix. So these two are the only viable prefixes as of now, right? Viable because beyond that the handle is not available, and therefore in my context of parsing, which basically I am calling as handle finding exercise, the prefix that goes beyond the handle is not of my concern at all, right? So let us look at it in a more detail. So, yeah, it's a very interesting slide and listen, a little stuffed. Please look at it and understand it. In the previous example, the viable prefix was either small a or small a and small b. But beyond that, it is not going to be viable as I am going past the handle. Now, how did I know the handle? I do not. I mean, will see that I know the handle, and I know therefore the viable prefix beyond AB is not viable anymore. So see, if the parser finds out the longest viable prefix, it can determine the right end of the handle. So now see we are going one after another. First we said we are trying to find out the handle. I mean our parsing algorithm will find out the handle. Then I'm a little revising it. I'm saying that no, it will not find out the handle really, but it will find out the right end of the handle from the beginning. So that is, it is finding out the longest viable prefix, and I know at the very end of the longest viable prefix, my handle is remaining. So from the right hand end, if the parser backtracks a bit, it may find out a match from the RHS of the production rules, and then it can find out the handle. Let me have an example. The same grammar and the same sentential form. The longest viable prefix is AB. Now I backtrack a bit and find out B is the RHS of a rule A produces B. So now B is the handle, and I replace this B by A, B, C. Now take another sentential form: small a, capital small b, small c, d, e. I know that this is my handle. How did I know? We'll talk about that later. Let us say I know that this is my handle. So what is the longest viable prefix? That is capital A, small b, small c. So if the parser finds out that this capital A, small b, small c, it backtracks from here and finds out capital A, small b, small c is the RHS of a rule like A produces capital A, small b, small c. So it can declare that this is the handle as of now. So if what I wanted to show here, if the parser can find out what is the right end of the handle, then the parser can also find out the left end of the handle by backtracking a bit. Right. So therefore, now the parser's task is to find out the longest viable prefix. Correct. So now we'll actually go to a very interesting stuff, and that is how to find out a handle. This is the biggest question now. Now you should have pen and paper along with you while you read this particular slide. You should see that there is a grammar. This grammar is not the previous grammar. This grammar is a little more elaborate, and you can see that this grammar has a recursive rule. You can see that from B I can go to C, so this is recursive. From A I have a left recursion, so it is a recursive grammar, left recursive as well as recursive grammar, and I am choosing a simple sentential form here. So I am in the spree of searching the longest viable prefix of this sentential form. Now I have not looked at this sentential form at all, and I am asking me a simple question: how could I find out? How could I find out the longest viable prefix? What do I know? Only thing I know is the sentential form is obtained from the start symbol. So if it is, now I look at the production rules. If it is going to be seen, what I have seen about the viable prefix, epsilon, null. What I want to see, the remaining part. So since I have not seen anything, I am trying to ask what could be the starting point of my viable prefix search by which I can start. So of course I can start with S. Now if I can start with S, there is a rule like S produces C, then I can jolly well not argue that I can start with capital C as well. Now if you say that capital C can be used to generate the remaining part of the viable prefix, I have a rule like C produces AB. So therefore, AB could be the other one by which I can find out my viable prefix. Now since this dot precedes this capital A, so A produces AA could be another way to find out my viable prefix, or A produces A could be seen as my starting point of the viable prefix. Now do understand one thing, that you see this, I mean the same production rules almost is written here with a dot. Now the moment I have a dot in a production rule, it is not a production rule, it is called an item. Now this item basically tells me that my viable prefix so far is null, and it next symbol could be capital C. And if the next symbol is capital C, maybe it is not really capital C, but it could be capital A followed by a capital B. Now, if it is a capital A, then it can be just a capital A followed by a small a. Then it could be a capital just a small a. It may start with. So I do not know as of now what does it start with, right? But I know that whatever it will start with, that will either start with a capital C, or will start with a capital A, or will start with a small a. Now let us see how it is starting. I see that it is starting with capital A. So I know that out of all these items, some items will be very essential for me now, which will take me beyond A. Now, can I see A from this item? No, because it says that I want to see C next. Can I see A, capital A here? Yes, I can. And if I see capital A, then this dot goes to here. It travels past A and comes to here. Similarly, is this a possibility? Yes, it is a possibility, but then this dot will come here. Now, is this a possibility? No. It says that the sentential form should start with a small a. So if I say that my next symbol was A, then I have only these two options coming from I0. C produces capital A dot capital B, and A produces capital A dot A. So what I am sure is I have already seen the part A. I have seen the part A. What is the remaining part? I do not know, but my question is how can they start with? So one answer is it can start with a capital B. The other answer is it can start with a capital small a. Now, if it starts with a capital B, I look at the production rules again, then it can jolly well start with a small b and then a capital C, or it can just be a small b. To remember these facts, I write down these two items as well here. So I got two items by simple go to, and then I close this set. I added two more items in this set so that I can say if I have already seen capital A, what I am going to see, could be capital B, could be small a, uh, uh, and beyond that could be capital C or nothing possible. Now it says that I see again a capital A. Sorry, I see it's A B. So it says yeah, I have seen A. It says I'll be seeing a small b. So from here, if I see a small b, where do I go? So again, to understand that question, to answer that question, I check here where dot precedes small b. So there are two items where dot precedes small b, and then this dot may travel over this b to come here, and this dot may travel over here to come here. So I get two basic items. B produces small b dot capital C, and capital B produces b dot. Now capital B produces B dot tells me could be I have reached the end of the handle, and capital and the other one tells me no, maybe I am going to see more. So what more? It says that I have already seen capital A small b, but maybe the remaining part could be a capital C. Now if it is a capital C, again I go to these rules. It could be a capital A and capital B. Since it can start with the capital A, again it can be either of these two. So these two items came from the go to, and these three were added when I try to close the set. The closer in the sense sets are closed, groups are closed. Now you understand that from I2, so you see at I0 what is the variable prefix I have seen? Null. At I1 what is the variable prefix I have seen? A, capital A. At I2 what is the variable prefix I have seen? Capital A small b. Then again I see a capital A. So from here if I see a capital A, where do I go? I go to C produces A dot B and A produces A dot A, right? And therefore I go back to the same state I1, right? Very interesting. So now you also understand that this state I1 is valid for a variable prefix which can be capital A, small b, capital A, or it could be capital A, small b, capital A, small b, capital A. After all, the number of such states is finite. Why are they finite? How many rules are there? 4, 1, 2, 3, 4, 5, 6. What is the maximum length to the right hand side? 2. How many dots may be pressed there? 1, 2, 3. So how many maximum items? 18. With 18 items, how many subsets can be created of it? 2 to the power 18. That's it. So this number of set will never go to 2 to the power 18, but nonetheless it is finite. But the sentence number of sentences this grammar will be generating will be infinite. So every state is responsible to be viable, to be valid for a number of viable prefixes, just not one. It is valid for the viable prefix capital A. It is also valid for the viable prefix capital A small b, again capital A. It is also valid for the viable prefix small capital A small b capital A, again small b, again small a, and go on and so on. It's a cycle. I can run the cycle as many times as I wish. Right. Now I have capital A small b small capital A, and now here I see I got a B. I mean here I'm here and I see that I got a, I mean I am here, sorry, I was here, I was here, I was here, now I am here, and now I see that I got a capital B. Now if I get a capital B, what are the items here that I need to concentrate on? The items for which dot precedes capital B. How many items? Only one item. And what does it say? It says that that is the end of it. What does that mean? That I have come to the right end of the handle. And what is the handle? AB. Why AB? Because there is AB. I mean, AB is the right hand side of the production rule. The state clearly maintains that, right? And therefore, for this sentential form, if I want to parse, I can follow these states, and I can tell you that the handle is AB, and then you can change AB to C, and you can go back to the previous sentential form, and then again start from here, and you have to traverse maybe different paths. This is very important to understand. I urge you to do it in paper and convince yourself. The difference between an item and a production rule is the first thing to be understood. If a production rule has a dot at the very beginning, at the very end, or in between the symbols of the right hand side, then that's an item. A number of items are clubbed in a particular group. Why? Because they are valid for a particular viable prefix, meaning that if the viable prefix, some part of the viable prefix has been seen already, and then the remaining part can be seen. How? That is the question, and that how is answered by whatever symbol appears to the right of that dot. For example, the question here was what are the items valid for a viable prefix called null? I have not seen anything. So since I have not seen anything, how do I do? I start with the start symbol. Yes. So I did say, so I said maybe the first symbol in the sentential form is capital C. But the moment you say it could be capital C, I know that after all there is a rule like C produces AB. So naturally C produces dot A. So that this just means that maybe your viable prefix may start with the capital A, and after that it could be capital B. It says that it may be capital A and then the next one could be small a, or it says that your viable prefix may be, and the next symbol in the viable prefix may be just small a. Now somebody opens this up for me and gives me the first symbol present, which is capital A. Now once I get this capital A, I ask the same question. I mean, if I see capital A here, what items are the ones that I choose? The ones that I choose are the ones in which dot precedes a capital A. How many of them? 2 of them. So this says that if I have seen A, then the remaining part could be seen from B or could be seen from small a. If it can be seen from small a, nothing else is possible because it is a terminal symbol. But if it is seen from B, then it may not be really B. Why? Because B has 2 rules. So it could be a small b followed by capital C, or it could be a small b followed by nothing possible. So therefore I add these 2 here. Why? Because these 2 items are also valid for the viable prefix capital A. I mean, if the viable prefix that I have seen is capital A, what could be my next symbol? It could be just small capital B, it it could be just small a, it could be just small b and followed by a capital C, or it could be just a small b and nothing. Now the I am given that yes, the second symbol is small b, so I am here, the second symbol is b. I prepare the first items from state I1. So these are the items I choose. Why? Because dot precedes small b. So I choose these items and I write B produces B dot capital C and B produces B dot. And I'm waiting to see whether some more can be added to this set. Yes, they can be. Why? This dot precedes a non-terminal and this non-terminal has certain rules. Now this non-terminal, so if it can be C, it could be A followed by B as well, or it could be A followed by A small a as well, or it could be just a small a, right? So at the moment I say it is an a, then a could be, as I said, dot, a, the rules for a also become very important now. So this is the way, one tells me what is the next symbol and I go and find out what state I'm in, and there and thereby I'm reaching some place where I have no go to, but there is a dot at the very end. I take that dot, and that if the dot is at the very end, that tells me I got the handle, reduce it. Now what is handle reduction? Handle reduction basically means that replacing the right hand side of a production rule by the left hand side in the sentential form. So our whole process of bottom up parsing becomes a series of handle reduction. Given a sentential form, reduce the handle, get back to the previous sentential form, again find the handle, reduce the handle, get back to the previous sentential form. Once you find the handle, reducing the handle basically means that you have the handle, so replace this handle by the corresponding left hand side. So the handle is reduced. Basically the sentential form is reduced, right? So this is called a reduction step. So I hope that this should be very clear to you, and let me go to the next slide then. See, even if I do not know what could be my sentential form, I could draw this DFA. You see, because from this state, where can I go? I can go to capital. I can go past capital C. I can go past capital A. I can go past small a. Exactly three outward arcs are there: capital C, capital A and small a. Then I created these sets of items, as I said. Then from here, what are possibilities? Capital B, you see, capital small a, you see, small b, you see. Here, dot precedes capital C, dot precedes capital A. So I can go to and small a. So I can go to from here, going past small a, and then I reach I5. So you will come back to states. It's not that you will get infinite states, and you will get a graph which is cyclic and which is cyclic. You will get the graph which is cyclic, right? So so I let me put that out in a better form. Yeah, you see this. So that diagram is replaced by this diagram, where the details of the sets of these states are not mentioned. So now you see this was easy to parse. You see, you are given me A B A B. What I do, I go from zero. Go from zero on A 1, on small a 2, on small b 5, and if you look at the 5, if you look at the 5, you see it is reduction step. It says that I have come to the end of the handle. Please reduce me, meaning change me by capital A, right? Yeah. So I understand that now. So also I did one thing. From 0 on A, I went to 1. From 1 on B, I went to 2. From 2 on small a, I went to 5. Right? I remember that. Maybe I put this in a stack. We'll later on see. And then this small a, it is replaced by capital B. I, uh, oh, oh, A B A B. So I believe that I should not go to this. What is 2? Yeah. Here you see, there is a small problem. I'll talk about that. So I should not go there. I should in B2, since in the second set I have a I could reduce because there is a, something like b produces b dot. I should have used that, so I do that. And then here you see, uh, if I get AB, then I come from 0 to 1 A, 1 to 2 B, 2 to 1 A, and 1 to 2 again B. And then this B is replaced by capital B. So I get AB, capital A, capital B. Now from here, if you do, I come from 0 to 1 by A, 1 on small b, 2 on small a, uh, uh, 2 on small a, uh, 1, and then 1 on small, 1 on capital B, 3. So this is 0 A1 B2 A1 3 B3. So this is, there is one thing missing here, 0 1 2 1 3, right? So in the slide that will be given, this will be corrected, but in the remember, whenever you listen to the slides, remember that this here there is a correction here. It will not go up to this 5, and similarly here there will be an addition of 1 from 2 to 1 and then 1 to 3, which is visible in this line, right? So you go on doing this handle pruning. Get the handle, reduce it. So you prune the handle. It is called handle reducing, it is called handle pruning. You get the handle, reduce the handle, prune the handle, get back to the previous intentional form, start again, right? Whether you need to start again or you can start from the intermediate stage, we'll talk about that later. But this is the whole crux of a bottom up parser in an LR method. uh, I hope that you enjoyed the lecture up to this, and this is the first lecture that I give. Uh, this is the same slides, same video that I will be uploading for 3A and 3B today. Uh, 3A students, I mean, today is a Wednesday, so 3A students may see it, and I mean, I'll go to the class once, but I'll assume that you read this first, you listen to this lecture first, then come to me with questions and answers. I'll be happy to do that. But please uh, use this video lecture to learn and listen and learn at your own pace, I mean, at your own pace, at your convenience. So thank you very much. This is all that I wanted to tell you about the in the first lecture of my bottom up LR parsers. Thank you very much.